Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is the third on a series on complex numbers. You should have already watched a video on what is a complex number, what is the imaginary unit, and then the previous video, which is graphing complex numbers in the complex plane. We now start working on what is the process we go through when we want to add, subtract, multiply, or divide complex numbers. In this video specifically, we're going to just deal with adding and subtracting them. And what's nice about it is that they act just like polynomials. So the how-to works like this. Given two complex numbers, if you want to find the sum or the difference, you're just going to identify the real parts of both the complex numbers that you're dealing with and the imaginary parts of the complex numbers you're dealing with, and you'll add those like parts. It's easier to see than to say, so let's go ahead and take a look at what I'm talking about. For the complex numbers given, we're going to graph them, compute and graph z1 plus z2, and then compute and graph z1 minus z2. Here are the complex numbers. z1 is just -2 plus 7/3 I. z2 is 1 plus I over 2. Note, there's a little bit of an issue with z2. z2 here is written not in standard form, and that makes it very difficult to graph. So what we're going to do is go ahead and take a moment to rewrite z sub 2 in standard form. And that would be just 1/2 plus I over 2, which I'm just going to call 1/2 I. That is much easier to deal with. Now we'll go ahead and graph both of these. And here you see I've graphed the real axis, the imaginary axis, just like we did in the previous video. And I'll go ahead and just plot out very quickly these two numbers. One thing you should note here are the magnitudes of these complex numbers, or maybe I should say is the magnitude of each of these complex numbers. For example, z sub 1, its real part has a magnitude of 2. In other words, we have to have our real axis at least go out to 2. Our imaginary axis has to get all the way to 7/3. In the z sub 2, you could see the real axis only needs to get to 1/2, and the imaginary axis only needs to get to 1/2. But that gives us a scale to work with here. So I'm going to go ahead and scale this to be a 3x3 or maybe a 4x4. So let me go ahead and mark that stuff up. Now let's pretend that those are equidistant and they're all of distance 1, right? So this point right here would be 1, and that would be 2, and so on and so forth down the line. So z sub 1, we'd go back 2 in the real direction and up 7/3, which is 2 1/3. So I'm going to go back 2 right to here and up 2 1/3. So somewhere right about there. And that would be the point z sub 1. I'm not going to write out the z sub 1 that is equal to -2 plus 7/3 I. I'm just going to call it z sub 1. All right, z sub 2 is 1/2 plus 1/2 I. So over 1/2 in the real direction and up 1/2 in the imaginary direction, and that would be z sub 2. Now we are asked to add those two complex numbers. So z1 plus z2. We concentrate on the real parts here, -2 and then a 1/2. We'll add those up. Obviously, you know how to add, so that's going to be a -3/2. So the sum of those two is going to be a -3/2. And let's see, now we're going to go ahead and focus in on the imaginary parts. Let me use a blue highlighter for that. And we have 7/3 and a 1/2. If you add those two up, 7/3 plus 1/2, you can see that's going to be what, 17/6. And now we're going to plot that, -3/2 plus 17/6 I. -3/2 again, is right around here. That's negative 3 halves. And up 17/6, that's almost all the way to 3. So I'm just going to go ahead and plot that right about there. Again, well, maybe I could go over a little bit more. That is going to be the point z sub 3, which is the sum of z1 and z2. Now I want to know, what about the difference, z sub 1 minus z sub 2? I'll write that over here again. So we have a negative 2 minus 1/2. So a negative 2 lose 1/2 more, and you're at negative 5 halves. That's the real part there. And positive 7/3 minus a 1/2, which is 11/6. And we'll go ahead and plot that. Negative 5 halves is negative 2.5, so somewhere around here. And then we go up 11/6, which is almost a 2. And I'll call that, by the way, z sub 4. Why not? So that is how we would add and subtract numbers. Normally you would not even bother plotting them, but this problem just asked us to. But adding and subtracting numbers, you're just adding and subtracting their components, right? The real components and the imaginary components.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.